I want to now look at another example of solving side-side angle triangles. Okay, in this example, I'm asked to solve the triangle where side A is 3, side B is 5, and angle B is 35 degrees. We know that this is a side-side angle problem because we're given two sides and we're given an angle that's opposite of one of those sides. As I mentioned in previous lessons, please don't try to draw these triangles. And the reason being, we don't know if they're going to form a triangle. We don't know if it's going to form one triangle or two triangles. So let the math do the work for you. We'll make our discoveries as we go through the problem. The first thing we can do is we can use our law of sines. We can set this up as sine of the two things that we know that go together, which is the 35 degrees and the side B, which is 5. And then let's say that we want to find angle A. We can use sine of A divided by 3, which is side A. To solve this, we can multiply both sides by 3 to get the sine of A by itself. The 3's on the right-hand side cancel. I'm going to rewrite this so that I have my sine of A on the left-hand side. And then on the right, I'll have 3 times sine of 35 degrees, and then divide by 5. I want to actually find the value on the right-hand side. This value will tell me if I have a triangle or not. Make sure that when you enter the right-hand side into your calculator, you're in degree mode because the 35 is in degrees. And what you're going to see is you're going to see that this equals 0.34414586818. Okay, now sine is always, the value of sine is always in between -1 and +1, and we see that 0.344 and so forth, this value is in between -1 and +1, so we're going to get an answer out for this problem. To solve for my angle A, I'm going to have to use an inverse, so I'll say sine inverse of 0.34414586818. That will give me the value of angle A. Okay, type that in your calculator. You'll get that angle A is equal to 20.1296647.2, and this is in degrees. Okay, now I'm going to call this particular angle A sub 1 because we know that there's a possibility that I may get two different values for my angle A. To figure out the other value for angle A, we may have A sub 2 equaling, and the way you compute A sub 2 is you subtract 180 degrees minus the angle that you just found, and this was explained in an earlier lesson. Okay, so that equals 159.87033353. Okay, now that you have a possibility for your second value of A, you need to check and see if this is actually going to work with the information that you're given. Okay, so we need to check and see if the value of that second angle A is possible. And here's the way you do this. There's a possibility that that second value for angle A may be too large. And to figure out if it is too large, take the angle that you were originally given. In other words, in this particular problem, you were given that angle B was 35 degrees. If angle A sub 2 is too large, then when you add 35 degrees and the value, you're going to get something that's either 180 degrees or larger. Okay, so on here, to check, take 35 degrees and add the 159.87033353. Okay. Well, if you add those two values, then we end up getting 194 point some odd degrees. And this is larger than 180 degrees. And so you see that that second value for A actually will not work. All right, so A sub 2 won't work. All right, what that means is it means that we have only one triangle possible for this particular problem. Earlier lessons told us that for side-side angle triangles, you have three possibilities. You're either going to have exactly one triangle possible, exactly two triangles possible, which we saw in a prior example, or you're going to have no triangle at all possible. Okay, in this case, this is where we have exactly one triangle. Okay, so what we'll do is we'll go ahead and take the information that we had. So we'll say A sub 1 was the value 20.1296647, and we'll go ahead and solve for the rest. Okay, on here we can take, to solve for C, we can take 180 degrees minus the 35 degrees we were given minus the 20 point some odd, and we can find out that angle C is 124.870335 degrees. And then the last thing we need to do is we need to find side C. Okay, well, to find side C, we can use the law of sines again, use sine of the angle you were given originally, divide by the side that went with the 35, which was 5, equals, and then you can do sine of angle C, which is the 124. Make sure you use all the decimals because you want to try to be as accurate as you possibly can. And then we don't know side C. Okay, to do this, I'm going to multiply both sides by C to get that out of the denominator. And then from there, okay, I will have this equation. Okay, and then finally what I need to do is multiply by the reciprocal of what I have on the left-hand side there behind the C value. Okay, so I'm going to multiply both sides by 5 over sine of 35 degrees. Okay. On this side, because I'm multiplying by reciprocal, everything cancels out except for the C. And then on this side, when I plug this in the calculator, I can plug it in like this. I'll clean this up a little bit. Okay, and then once again, just make sure that you're in degree mode. Go ahead and enter in the right-hand side of that equation, and you'll end up getting 7.1520712. Okay, so now you have all information that you need for this particular triangle. I'll go ahead and kind of put everything together. Okay, so angle A was the 20.1296647 degrees. Okay, we ended up with angle C being 124.870335 degrees. And then we ended up with side C being the 7.1520712. On this, what I want to do is I want to re-emphasize that when checking to see if there is a second angle, that's possible, be sure that when you add the obtuse possibility, okay, Okay, in other words, what I mean by that, when we solved for angle A here, we were left with two options. The first option was that angle A was the 20 point however many degrees. Okay, that's the acute one. And then when we subtracted 180 minus that, we got that A2 was possibly 159 point whatever degrees. If you take that obtuse angle, the one that's more than 90 degrees, make sure that when you add that obtuse possibility to the angle given, you get a measure strictly less than 180 degrees. If not, there's only one triangle. Okay, now this concludes this lesson on solving side-side angle triangles.